Hey mathematicians, today we're going to learn about scale drawings. Our learning target is I understand that scale drawings are figures that are identical in shape but not in size, with side lengths in equivalent ratios. So we've got some vocab we need to know. We need to know that a scale is a ratio of length in a scale model to the length of the real thing. Then we need to know about scale factor. Scale factor is the number used to multiply or resize a shape. So you have probably seen scale before if you've ever gone down the aisle in the toy store that has the model cars and you've seen a 1 to 16 scale model car. That is the scale right there, telling us that 1 unit in the scale model corresponds to 16 units in the real car or whatever is being built. All right, so we are going to do problem number 1. This is an ID problem. What is the scale factor from figure A to figure B? So remember, scale factor is what are we multiplying by to get from one shape to another. They're saying from figure A to figure B. So from here to here, what are we multiplying by? So first I want to look at corresponding sides that are the same. So I'm going to look at these guys right here. If I look at that obtuse angle, I can see that the 6 unit side and the 30 unit side are the same, right? So I'm going to figure out 6 times what gets me to 30. Well, we probably know that, right? We know our multiplication facts, but just in case we don't, we can say 6 times x equals 30. Oh, hey, we've done these before. This is 6th grade math. We solve it by doing inverse operations, and that gets us x equals 5. So what is our scale factor? It is 5. Next we can look at 2. What is the scale factor from figure A to figure B? So again, we're going A to B. So let's find our corresponding sides. I'm going to go with this acute angle up at the top, and let's use this side here. So I've got 6 to 36, so 6 times x equals 36. Again, you may know your math facts. You may know what x is equal to. But if you didn't, if we had some trickier numbers like decimals or fractions, we would want to set up our equation and solve it. The opposite of multiplying by 6 is dividing by 6. That simplifies to 1x. And I know 36 divided by 6 is 6, so the scale factor is 6. Number 3 is a you-do problem, so I want you to pause the video, try it, and come back when you're ready to check your work. So please press pause now. All right, so the sides that I chose were the 2 top sides there. Those are my corresponding sides I looked at, this guy and this guy. And we're going from A to B, so I want to know what number would I multiply 6 by to get to 10. So I set up my equation, 6x equals 10, divided it out, and it got me kind of a wonky number. This is when writing that equation really helps. So you could say that x is equal to 5/3, or 1.6 continuing, or 1 2/3. Those are all the same way to say the same, or different ways to say the same amount. Number 4, what is the scale factor from figure A to figure B? This is another you try it problem. So I'm going to ask you to press pause now and come back when you are ready to check it. Press pause. Welcome back. You can see here I use that shorter side, and I set up, since we're going from A to B, I need to figure out what I multiply A by to get to B. 3x equals 4, figuring out what x is. X is 4/3 or 1 1/3 or 1.3 continuing. It is totally okay if you did 12x equals 16. You're still going to get the same answer, although you would need to simplify that fraction. 4/3 would not be your initial answer. You'd have 16/12. All right, number 5, we are figuring out, is figure B a scale copy of figure A? For it to be a scale copy, number 1, it has to be the same shape. Is it the same shape? Yes, it is a trapezoid. Great. And you have to be able to multiply all of the sides on figure A by the same number to get their corresponding sides on figure B. So let's start with this short side here, and I'm going to figure out what do I multiply 4 by to get to 2. I'm going to multiply by 1/2. Okay, cool. So 4 to 2, I would multiply by 1/2. Love that. Let's move around. If I want to look at this kind of slanted side here, I've got 10 to 5. If I do 10 times 1/2, will I get 5? Yes. Okay, we're good so far. Now let's look at the bottom side, this longest side. I'm going from 10 to 6. Already I'm seeing some red flags because up here 10 took me to 5. Now 10 is taking me to 6. I don't like that. If I do 10 times 1/2, am I going to get 6? No, I'm not. And if we actually look at the other side as well, that one that goes straight up and down, that one is also a problem. Oh heck, that didn't work well. Because 8 times 1/2 is not 6. So, is figure B a scale copy of figure A? Emphatically, no it is not. I cannot multiply all the sides on figure A by 1/2 to get all the sides on figure B. Okay, let's look at figure 6. You guys are going to help me out with that one. Is figure B a scale copy of figure A? The figures are not drawn to scale. They're not drawn to scale, but that's okay. We can look at the side lengths of the triangles. So let's start with, first I notice we've got a right triangle, right? And I'm going to look at this side right here. That is 2 units tall. Looking at this side, 2, 4, 6 units. Okay, great. I know that to go from 2 to 6, I would multiply by 3. Now let's look at the bottom side. 1, 2, that is 2 units. And that is 6 units. To go from 2 to 6, I'm multiplying by 3. Now finding that slanted edge, that longest side here, that is a little bit above 7th grade math, but I can tell you if you've got this right triangle and you know that those 2 legs, the 2 shorter sides, are correctly scaled, then that longer side will be correctly scaled as well. So, is it a scale copy? Yes, everything scales up by 3. Number 7 is a you-do problem, so I would like you to attempt that problem. Please press pause now and come back when you're ready to check it. Alright, you can see here that when I looked at the top sides of that trapezoid, I went from 2 to 10. I know that that is a scale factor of 5. The side length got 5 times bigger. So then I moved to the left and I looked at this kind of up and down side, and I went from 2 to 11. Well, I know that 11 divided by 2 is 5.5, so that scale factor must be 5.5. I've got 2 different scale factors. This is not a scale copy. All right, number 10. Alexander is drawing a map of the Federal Triangle in Washington, D.C. Immediately, I'm thinking, okay, Federal Triangle, let's picture that. It is a triangle. The Federal Triangle has a base of 3,000 feet and a height of 1,200 feet. Alexander needs his drawing to fit on his paper, so he decides to make the base of his triangle 10 inches. The base is this amount right here. So I've got to figure out, if I'm going from 3,000 feet to 10 inches, that's obviously a bit of a change, right? They want to know what scale he is using. I'm going to use a table to help me figure out this scale. So I'm going to first, I just realized I got ahead of myself, but that's okay, we can do number 10. I'm going to set up first my units. They started with inches, so my first unit is going to be inches, then I'm going to list feet. And then they have 1 inch and an unknown number of feet, so that's what we're looking for, okay? We know that the base of his triangle is 10 inches. That's inches, so it goes up here, 10 inches. And the base of the real triangle is 3,000. So I have to figure out how I could find that missing amount. Well, I know that to go from 10 to 1, I'm just dividing by 10. So then I could take 3,000 and divide by 10, and that gets me 300 feet. That means every 1 inch in his drawing represents 300 feet in the real world. So now we can find the height of his triangle, and we're going to keep using this table. The height of the triangle in the real world is 1,200 feet, and we're looking for inches. So I know to go from 300 to 1,200, I'm going to multiply by 4. If I didn't know that, could I divide? Absolutely. So then I do 1 times 4, and that gets me 4 inches. All right, our next problem says a scale on a hiking map shows that 1.5 inches represents 4 miles. What number of actual miles are represented by 6 inches on the map? This is another problem where I would recommend using a table. So we're going to compare inches to miles. And they said that 1.5 inches represents 4 miles. So make sure you match those units up. And they want to know the number of actual miles that are represented by 6 inches on the map. Now, I don't know off the top of my head how to get from 1.5 to 6, but I do know if I double 1.5, it takes me to 3, and then I can double it again to get to 6. So we're allowed to do that. If I'm going to double the inches, I also have to double the miles. And that tells me that 6 inches on the map would represent 16 miles in real life. All right, number 9. Figure A is a scale image of figure B, so we know it is going to match up. If we multiply this side by one number to get that side, then we're going to do the same thing for any other side. We're looking for the value of x. So let's do ratio of A to B. I know that this side that has a length of 3 corresponds to that side that has a length of 4. And then, oh, I just messed it up. Hold please, I've made a mistake. Figure B has a side of 3. Figure A has a side of 4. It's important to pay attention to those details. Mathematicians need to attend to precision. And then figure B has the longer side of x. Figure A has the longer side of 7.2. So now I can do like I did in my previous step and jump here to there. But, oh my gosh, I didn't need that. But I'm not really sure what I need to multiply 4 by to get to 3.2. Seems a little bit, oh my gosh, you guys, I'm really struggling. Seems a little bit challenging to do. So instead, I'm going to work from one figure to the next. I'm going to use that scale. Okay, I'm going to use that scale factor. I want to go from B to A. So B times something equals A. B is 3, and A was 4. So I can divide out. X must be 4/3. So I know that to go from B to A, I would multiply by 4/3. Or if I wanted to go the other way, if I wanted to go from A to B, instead of multiplying, I could do the opposite. I could divide by 4/3. And this is where you want to get your handy dandy calculator out. You're allowed to with this unit. It is totally okay. And that gets us x equals 5.4. Okay. I should have chosen a different variable for that. I apologize. This x should have been like y or z or whatever, because that should have been y or z or whatever. So I'm sorry. Number 11. Rena is building a 1 to 180 scale model of a real castle. Her model has a rectangular base that is 3 feet wide and 4 feet long. What is the area of the base of the actual castle in square feet? So not only are we finding a side length, we need to use it to find the area, and we're looking for the actual measurements. I'm going to have you press pause when you're ready. Come back and hit play and check your work. So go ahead and hit pause and work it out now. Okay, you can see here that the area is 388,800 square feet, and over here is my table to show how we got that. Would it be acceptable if I didn't want to go from one measurement on the scale to the next? Could I go from scale to real? Absolutely. I could do scale times 180, which would mean I would do 3 times 180 and 4 times 180. That will still get me 540 as one of the measurements, and the width, and 720 as the length. Once I know the length and the width, I can multiply them to get the area. So on your notes, I'd like you to sum it up. What do we need to remember? What is important? And we will do some practice problems on this tomorrow.